Hello, everybody. Testing, testing. Oh, good. I see audio levels. Always got to check the audio levels first. Hi, everybody. Welcome to the Astro Coffee Hangout. It's Thursday, 3 o'clock. We are here every Thursday to talk about astronomy and do all kinds of stuff. First up, I just got a couple of programming notes. You guys probably were expecting a hangout with the EV Scope guys, the Unistellar guys. Well, we had to reschedule till next week because I wasn't ready. It wasn't their fault. It was their fault. I haven't had a chance to use the scope yet, and they don't want me to do the hangout until I've had a chance to use it. And so it's sitting right here, set up and ready to go. But the weather has been crap. We just had a big front move in last night, lots of rain and thunderstorms, and so I couldn't use it last night. But now, although here in Central Florida it's cold AF, it's still, it's clear, so I'll be able to use the scope tonight. And that's another thing that's been happening is that my video has been going out. So hang tight, folks. I'll be right back. I knew this would happen during the stream. So this Zoom meeting has just been randomly stopping my video. There, I'm back. Oh, now it's not going to let me do it at all. There we go. Okay. And so it's just been randomly stopping my video, and now it's not letting me do it for any length of time. Crap. Okay. Well, what you are now looking at is one of my guests, Mike Forsland. He's the only one that's got a video camera that apparently is working right now. Hi, Mike, and welcome. Thank you for joining us. But let me try one more time. Please come on and stay. Why are you not staying?
There's something
weird. Yeah. It's not even using the right camera now. I think it's my, there it goes. Well, hopefully it'll stay. Oh, this is the fun of live television.
Yes, okay. That's right.
All right.
The fun of live television. Exactly.
All right. So instead of doing the hangout with the EV Scope, which will be next Thursday, same time, today we are going to be talking about this new object that you may have heard about in the news about whether or about they're calling it a mini moon. We have a new moon. It was just confirmed recently by the International Astronomical Union's Minor Planet Center. And it is out and about the Earth, very dim, very small. So to talk about this, I was able to grab my good friend Mike Forsland and Sam Dean, both of whom are with us here, and they are part of something that we're going to be talking about a little bit later on in the hangout, which is
hi.
Yeah, that's right. Mike
Sam.
doesn't have a camera either. Or I'm sorry, Sam doesn't have a camera either. He's joining us by audio only. But these guys they have a YouTube channel called Asteroid Hunters, which I want you guys to definitely subscribe to. The link is in the description box of this video. Also, they do a Twitch stream, several times a week. I don't know if you do it regularly, Mike, do you?
Yeah, well, we try to. It just kind of depends on what's up and what needs observations.
Okay.
So then we try to do a few times a week if we can.
Good. Okay. Well, so follow them on Twitch at switch.tv/Asteroid Hunters with an underscore in there. And it's a great stream. They've got a lot of really good stuff, and they're going to talk about what they do a little bit later on in the hangout. But first, Mike and Sam, who wants to go first? Now, Sam was telling me that he actually wrote a lot of the information that's in the Wikipedia page about this object. But what I want one of you to do is to introduce it to us. What is it? And, tell us a little bit about when it was discovered and all of that kind of stuff. Who wants to go, Mike or Sam?
Go. Why don't you go ahead and talk, Sam, about it? Sam seems he does know a lot more about this object than we do, since it is much newer object. But this is right up Sam's alley because it's kind of an unusual object that comes flying into our orbit. So I know this is right up Sam's alley, and he's by far the expert on this.
Okay, take it away, Sam. Tell us a little bit about this thing. And while you're talking, I'm going to show the Earth sky picture of it that's on the webpage there. I'll just put that up real quick. Are you there?
Right. Hi,
Yeah.
I'm here. Sorry about that.
Oh, that's all right.
Anyway, effectively, this is a pretty unusual occurrence for us to have to do, to have to prepare for. So usually discoveries like this, discoveries of near Earth objects and stuff get done pretty quickly, and discovered in and out, and then they're confirmed and stuff. But this one ended up being kind of weird. Basically, what happened is on February 15th, the Mount Lemmon survey, or the Catalina Sky Survey, on Mount Lemmon, Arizona, discovered an object about 20th magnitude that seemed to be moving pretty fast, and they got a few more observations of it from other observatories over the next day or so. And at that point, it started to look suspiciously like it was orbiting us. Now, finding objects orbiting us isn't exactly a new thing.
Yeah.
We find things orbiting us all the time. But what was a bit different about this one was that it didn't look like it was an artificial satellite of ours. We couldn't link it to any kind of known objects that we knew we'd launched, and we tend to keep pretty good track of objects we launched this far out. So the question was, is this an artificial satellite that we forgot about, or is this a genuine rock that entered our orbit? So over the next few days, as it started dimming and getting further away from us, we got a few more observatories to follow up on it. And the main way that we're able to tell if an object is a rock or a satellite is actually due to a pretty unusual fact. Basically, rocks are solid. I know that's a really simple, dumb thing to point out, but it's important here because satellites aren't solid. So when the sun shines onto these objects, it actually creates a very slight pressure on them. And just kind of like a paper bag being blown by the wind versus a rock not being blown by the wind, when an object is really big but doesn't have a whole lot of density to it, that thing tends to get tossed around a lot. My good friend Bill Gray refers to them affectionately as empty trash bag objects, satellites that are just really like empty but have a ton of surface area, so they just get tossed around everywhere. So the main way that we can tell if an object orbiting us is natural or not is by observing it for a few days and seeing if it starts moving around weirdly like it shouldn't. So far, all of the observations that we've had, though, have indicated that it's not moving around weirdly, that it's behaving exactly like a rock would. So we think it's probably a rock. We've only been observing it for a week or so, but based on how we've projected it back into time, it seems to have been orbiting us since around late 2017 or early 2018, but is on its way out right now. It's not coming back again. It reached its closest point to us on the 13th, just before it got found. And right now, the moon has just tossed it out into orbit around the sun instead, so it's not going to be coming back for a while. Not until 2038, I believe.
Okay, so and this was recently just confirmed. So it was confirmed 2 days ago by the Minor Planet Center at the IAU, correct?
Yep.
Okay. All right. So and they before they confirmed it, and before they were able to say that this was a natural occurring rock, they got rid of they did what you what you were just talking about, which makes sure that it wasn't an artificial or something else, that it was actually a rock in space around the Earth, correct?
Yeah.
Okay.
Yeah, absolutely right on that. In fact, the funny thing is, a couple days after it got discovered, the Minor Planet Center was so not used to having objects just orbiting us that they actually removed it a couple days after because it's orbiting us, so it must not be a rock.
Yeah, it must not
so
be,
they removed it for
satellite,
not
right.
being an asteroid,
Exactly.
despite the fact that it was an asteroid.
Yeah.
Okay. Well, so can you show us via your screen share, either one of you, maybe Mike or Sam, the orbit of this thing, and let's talk about some of the characteristics of it.
You want me to pop that up there, Sam?
I've got the more
Okay, go ahead.
accurate URL of it, so
Yeah.
I suppose maybe I should. Let me get that up for you real quick.
All right.
Does that show up?
Hang on just a sec. Let me get rid of some of this
Looks
other
like
stuff.
it.
Yep, I've got it showing. It's being broadcast now, so we're looking at your screen.
Right. Ignore the straight lines right now. Those are just artifacts of the simulation. But this is a plot, a time lapse of its orbit back over the last few years as it kind of careened through our inner, like the orbit of the Earth and stuff, getting messed about by the moon. I want you to pay special attention to. Oh, it's really lagging today. I want you to pay special attention whenever it gets to it, to the time around March 20th to April 1st of 2019, because at that point, the moon really tosses it in, and it gets really, really close to the Earth. When we initially first observed it, we thought that the fact that it got so close to the Earth in March might be some indication that it got launched around March. But as we got more observations, it became clearer that it didn't actually. And from that point forth, the orbit kind of stabilized, and it seemed to have either entered our orbit in around December 2017 or maybe January. Right there. See that? See that right there?
Yeah.
That bit where it just like careens right towards Earth. I think it got to like 2,000 kilometers above our surface.
Wow, that's really close.
Let's also be clear too that this object is roughly 6 to 12 feet in diameter, just so everybody knows.
Yeah.
Oh yeah.
We're not talking about
that's where I was
afraid of. Just I'm seeing some of the chat. I'm like, oh man, is it coming in? It's like, just so everybody knows, this is a very small object. That's the reason why we didn't catch it, because it's a small object and much more difficult to detect.
Now, that's right. And we're going to talk more about what you guys observe with your equipment in just a minute. But this is too dim even for your stuff to see, right?
Oh, this is its last orbit. You see, the moon kind of messes about with it.
Yeah.
And then it just leaves our orbit right after.
Just out.
Okay.
Well, it's coming back again, but after this one, the moon throws it out too much for it to.
So because of the interaction that it's had with Moon and with Earth, it's currently captured by the Earth, and it is, but only temporarily. It's only going to be here until for another couple of more months, correct?
Yeah.
So it'll be
looking at the simulations. That is the case. I'm looking at the Minor Planet Center. It's showing only 52 observations on this object, which isn't a tremendous amount, but it seems to be enough to kind of understand what's going on with this thing.
Well, that's a pretty wild orbit, though. To be able to, for just 50 observations. So what kind of simulation is this? Is this just an algorithm that they're using for based on these 50 observations?
You'd probably have to ask Tony about that one. Tony Dunn of Orbit Simulator, but
okay.
As far as I'm aware, it's just a basic 3-body orbit simulating thing where it tries and calculates how the moon and the Earth are affecting how that thing is moving over time.
Okay. So this thing is small, folks, as they were just pointing out. It's dark, magnitude 30, I think, is what it is, and it's tiny.
It's only magnitude 24 right now. Only.
Yeah. Well, okay. Well,
only. Right.
Yeah. Let me just look up and see that. Yeah. So that is pretty. Regardless, it's really dim, and so the kinds of equipment that they're using to see this. Can you guys tell us a little bit about the Catalina Sky Survey? What do they observe with, and how often, and all of that kind? It's a sky survey, so presumably they do it every night, right?
Yeah, those guys are they're out every night. They actually do have a website based out of the University of Arizona. From what I understand, they remotely control their scopes up on Mount Lemmon, and they have a number of scopes. They've got a 1.5, a 1 meter, a 0.7 meter as well, and they're basically looking at these sky surveys. Now they have, from what I understand, they have one telescope that does kind of the big sky surveys, and then when they find stuff, they actually have a little bit smaller telescopes. They have one that's a 1 meter that is it's got a field of view of 0.3 degrees with a pixel scale of 1.03 degrees. This telescope recovers 40 to 80 targets, NEOs per night, with a limiting magnitude of 22, which is really dim. But these guys can shoot that in about 30 seconds with this. Some of their scopes that they have, they can get down to 19, 20 magnitude at 30 seconds with what they're observing. And they are one of the big players in this game. I mean, there's Pan-STARRS and a lot of other ones, but Catalina actually is by far one of the biggest as far as what they capture on a nightly basis and the things that they're imaging.
Is Pan-STARRS still taking data, or are they done?
They are still taking data.
Pan-STARRS is.
Yeah. Oh, okay. I thought it was just I thought they had run their
No, they're still doing a lot of that stuff. Atlas, a lot of who we work with Atlas as well, but Pan-STARRS is definitely in the game.
Okay.
mind if I mention something real quick?
I do not mind. Go right. Oh, by the way, your last name is Dean, Deen.
Yes.
Somebody
Yep.
was asking about that. So there you go, Sam Dean. Go for it.
I want to mention that although their telescopes aren't the biggest in the game right now, the Catalina Sky Survey is actually pretty much one of the biggest sky survey, the biggest sky survey, I would argue right now, in terms of their sheer number of asteroid discoveries and observations.
Yeah.
They've been in the game for like a really long time, the early 2000s at least, and they find basically 3/4 of all asteroids that are near the Earth at any given moment, and Pan-STARRS usually picks up the rest, but it's mostly Mount Lemmon, the Catalina Sky Survey, who's picking the big ones up.
Wow, that's really cool. Well, let's talk about the work that you guys are doing. So, as I mentioned at the top of this hangout, Mike and Sam and many others working with him look for near-Earth objects, PHAs, potentially hazardous asteroids, and all kinds of stuff that's up there. So, Mike, tell us a little bit about asteroid hunters and maybe a little bit about the equipment you're using, but more importantly, what you're doing with your observations once you take them.
So, Asteroid Hunters was kind of formed as a father-son adventure. My 15-year-old.
I'm sorry. Let me just interrupt you for a minute.
Okay.
Okay. You may. You watch their stream, folks, and you will see that where Mike is sitting right now it would make any NASA Hubble Operations Center look, Spartan by comparison. They've got quite a mission control down there. So it's really impressive. And to say that it's a father-son thing is really being very humble, because it's amazing the stuff they've got and what they're doing with it. Go ahead, Mike. I'm sorry I interrupted. I just had to say that. I've been, by the way, I've been to the Hubble. I've been to the Hubble Control Center at Goddard, and I'm here to tell you, your room there is more impressive.
Well, and part of that is that it started with my son and I building computers together, which goes way back. But we've always had a kind of a love for astronomy, and about a year ago, I started talking to him. It's like, let's try to do some science. Let's see if we can do something that really is meaningful in astronomy and utilizes the equipment, the massive computers that we've built and the things that we've put together. So we started on this about a year ago. It took us a year just to figure it out, because as you know, it's not a very well publicized science as far as what's on YouTube. I mean, obviously you go to YouTube to try to figure this stuff out. So we go to YouTube, and that's the first thing. And there's just not a ton of videos out there to try to understand how to observe, how to measure, and how to do those things. So, through about a year's time of trial and error and sending stuff to the Minor Planet Center and having them, come back and say, nope, you're not even close. And then we've had some great support from guys like David Rankin, who I reached out to on YouTube and sent some of my images to, and through that. So through the time, we've been able to understand, figure out. We've had incredible support from our friends at telescopes.net. That supplied us with amazing equipment to help out as well. And through that process, we were able to get our observatory code. And basically now what we do is we, on a weekly basis, we have in the last few months, we built an observatory right outside of our garage out here. And we open the door or the roof on this thing. And we look at, we take observations every night. And now we're collecting data, and we're sending it to the Minor Planet Center. Now, through this, what's been pretty incredible through this ride is that we said, hey, let's create this channel. Let's show how we're doing this stuff. It's really a father-son adventure, and we've had a great time. But through it, we were able to get hooked up with Mike Akey and the Worldwide Variable Star Hunter team. And Mike reached out to us and said, hey, we have a telescope in Abu Dhabi, a 24-inch plane wave, which Tony, you are a part of the team, and
right, we're going to be doing a hangout on that. In the
sure.
future.
So,
yeah.
And he reached out and said, hey, we're putting together a observation team to do real science for these big organizations, and and we want you to lead up the asteroid division. And I was like, whoa, okay, how did this happen? Well, he watched our YouTube videos and just was like, you guys know what you're doing. You've gone through the ringer, so here it is. So through that, we're starting to do some work with Atlas obviously the tests. We're doing exoplanet research with tests now. My son and I bagged a supernova for Assassin. We're working with Assassin, so we were able to get a supernova confirmation a few months ago. We got written up in the ATEL, which has just been incredible. And but through that, we found Sam, who is part of our team here. And Sam is just he's just an expert when it comes to this this science, and he's been a real resource for us, and we're just real grateful for him. But Sam's really, really great at what he really specializes in is finding lost objects. And he's walked me through times where he'll go through these sky surveys and he'll look at orbits of some of these objects that were seen years ago and try to reacquire them, which to me is like extremely difficult. But Sam will do it over these sky surveys, and I'm so impressed by that. But yeah, so we don't claim to be experts by any stretch of the field, but we are learning. And we are fortunately part of an amazing team. I want to show you real quick. If you don't mind, I'm going to screen share.
Yeah, go ahead.
Just real quick, our telescope here. So we recently just got we're running a 14 Edge HD. We are running Hyperstar. We want to shout out to our friend Dean there at Starzona, who is just taking care of us greatly on that. And
Not me,
so
though.
we are we are running a Hyperstar with a ZWO camera and a CGE Pro mount, and this is in our observatory just right outside of our door. So we are remoted into it, so we just control it right here from the garage. And this is our setup that we use on a nightly basis when we can, and that's pretty much our story. And like I said, this channel just keeps growing and growing and growing, and meeting gentlemen like you, Tony, that are interested in the science that we're doing, and we're just really fired up to be part of it. And my son, it's amazing to see my 15-year-old son involved. And
I love that about what you're doing.
So,
I really think that's amazing. So Sam, you start with you're one of the things you're apparently really good at is you take data from older surveys, the objects that have been found usually by automation, and then you try to reacquire them again. Is that correct?
Yeah, that's correct. I originally got into this sort of thing back when I was, let's see here, and I was 13 at the time. I was insane. I was basically trying to be like, man, I want to contribute to science and helping get like astronomy, space stuff better known, not just to the public, but just like in general. But since I'm 13, I really can't like get a telescope and start observing on my own. So what can I do? Turns out there's just a ton of already available space data that's been there for years.
That's right. That's
the
exactly
big surveys are just tossing out there.
It's free.
Like it's yeah, it is free. So I figured they can't possibly have like searched all of this dry. So I started looking around and found that they actually haven't remotely searched any of it dry. And there's just tons of stuff all over the place that nobody's even bothered looking at.
Yep.
I think some of the more interesting stuff that I've done recently is that there's a bunch of I assume you've heard of the Planet 9 hypothesis, Tony, but
yes,
just for anyone who's
in
not
fact, I've had a
on
hangout
that.
with Mike Constantine Badigan and Mike Brown, so we talked about it before. Yeah.
Nice.
Yeah.
Well, to catch anyone up who is not aware of it, basically,
They haven't found it
there's
yet.
been a lot of objects that are in the really far out of solar system that have really weird orbits that we can't really explain by them having been tossed into that orbit by Neptune or any other known planet. And all of them seem to have orbits that indicate that there's about a 5 or 10 times the mass of Earth object somewhere way out in the outer solar system. However, we haven't been able to see it yet. There's a lot of different people, including Mike Brown and Konstantin Bedijan, who are working on that. But none of them have managed to, at least they haven't declared that they found it yet. They're probably hiding on a few really good objects right now. Anyway, so right now the main thing for us plebeians without 8-meter telescopes to do is what I've been trying to do is find archival images of some of those asteroids that they've been using to imply it, and trying to find more images to know their orbit better. So if you know the orbit of the things that are being tossed around, you can probably find out the orbit of the thing tossing them around better. There was one that was 2003 SS422, total license plate name, I know, that was discovered in September 2003 and observed until November 2003. And I'm currently working on getting it a bit more than just 2 months of observations, because trying to plot the orbit of something that takes thousands of years to orbit with only 2 months of observations is just an exercise in futility.
Yeah, definitely.
But Sam loves it. He loves it. I know you live for this, Sam. I know you do.
It's awesome. It's awesome being able to look at like an image that was taken like 15 years ago and being like, I'm the first person to see this image.
Yeah.
And seeing an asteroid in that image and being like, I'm one of the first people to ever see this thing ever. Well, you can't really compare that with anything else.
And you know what's fascinating, Tony, too? Sam will come back and say, hey, this object popped up recently, but I firmly believe it was an object that we saw, 20 years ago or 10 years ago or whatever it was. And we had it for 2 weeks and we lost it. But when it came back in, we think it's a new object. But he'll show those orbits and you just go, wow, like,
yeah,
it looks like you're right, Sam. Like, it looks like that was the object that we saw 10 years ago and lost, and now we're just calling it something else as it comes in. And it's pretty fascinating to sit with him when he walks through this stuff and see those things.
And that's a skill set that's going to serve you real well, Sam, because I can tell you, having worked on these surveys professionally, there are certain science objectives that everybody's trying to get out of their data once these data are taken. And then, the Sloan Digital Sky Survey is a good example, right? There were lots of science. They were out to, map a lot of galaxies and get the large scale structure of the universe down with redshifts. And they did that with their first observing runs, and then they came out with data releases. They're still coming out with data releases. But what ends up happening is they get their first list of objects out, they publish their papers or whatever it is. Funding is either still there or not still there. If it's not still there, then the number of papers goes down quite a bit. But it relies on people like yourself and also other astronomers who are paid to do this, to look at these surveys and go back through them to try and find more stuff. Because you're right, there's no way you're going to get all of this stuff. I mean, I worked on the dark energy survey, and as the data came off the DCAM, we were able to get billions of galaxies, or billions of objects, I should say, some of which were galaxies, some were clusters, some were other things. But there's still the process of winnowing down these objects to make sure, first of all, they are what we think they are. And then with every data release, it gets better and better. It's the same with the other data sets you guys are using with Gaia, right? You guys use Gaia a lot to get astrometric information. So these data releases keep getting better, but it is incumbent on somebody to go back through this data and look at it a little bit closer. And the fact that you're doing it now, Sam, as a college student, I'm telling you now, if you want, I don't know what your career goals are, but if it is to go into professional astronomy, you're not going to have any trouble finding any work. I can promise you that.
Well, right now, I can assure you, I would prefer nothing more than for a big survey like the Dark Energy Survey to just take me under its wing and be like, Sam, find me a billion asteroids. And I'm going to be like, hell yeah.
Well, that was not one of its stated science goals. However, it's something that you can do when you take lots of images of big areas of the sky. The Dark Energy Survey only looked at 5,000 square degrees of the sky for 525 nights, and then it stopped. It was done. But you can still get a lot of, they were obviously interested in characterizing dark energy, but they were also looking at other cosmological parameters as well. But the side science that can be done is transients and things like this, because when you look at a big area of the sky, you see things moving through, just like this little moon here.
I was actually using... Oh, sorry.
Go ahead, Sam. No, go ahead, please.
I was actually using the Dark Energy Survey like last night to find a lost asteroid. I forget. I think it was one of those asteroids whose orbit always remains inside of Earth. Those ones that we've been getting really good at finding recently.
Mm-hmm.
I was actually using the Dark Energy Survey to try and find some images of it from back in 2016. It's a bit challenging because it was really close to the sun, but also because it's been several years ago. But the Dark Energy Survey still has a ton to offer, and Well, I guess thanks to both you and also the rest of the team who worked on that for helping that become a thing.
Yeah, and it's I want to talk a lot more about this in just a second, but I need to give some shout outs here. Yeah, with the chat, people are talking about Econ Greg. Okay, I want to have a hangout with Econ Greg on this channel at some point. But yes, he is also a Twitch streamer that has a great.
And he is part of our team for the.
He's
Worldwide
also part of the
Starners.
That's Absolutely. Right, WWSV. H or whatever, yeah, that's what it is. That's one of the longer acronyms. But he streams on Twitch as well. You got to go check him out because these people are doing, in addition to Asteroid Hunters and what Mike Akey is doing with the Worldwide Variable Star Hunters and Econ Greg, all of these people are making astronomy available to you in a variety of different capacities. Now, one of the things I want to distinguish are there's Twitch streamers out there, and there's also people on YouTube who are doing a lot of great backyard astronomy and taking of images and stuff like that. And I was talking about this with Akey the other day on Discord. One of the things I'm most excited about is the kind of things that people like, these guys, Sam and Mike from Asteroid Hunters, are doing is the science that can be done with equipment that you can just buy and set up. And, it took you said about a year, right, before you were finally ready to start streaming and things like that.
Yeah, well, I'm glad you're talking about this because that's what I wanted to talk about. Because I'm seeing in the chat, we had some people go, "How did you catch a supernova with that telescope?"
Yeah, go ahead, talk about that.
And I just, Econ Greg, who runs also an 11 Raza, has captured a number of supernovas for our team for Assassin, and I got to tell you, man, and you and I talked about this, Tony, when you were on our stream the other night. Is technology now? These cameras are just allowing you to do so much right from your backyard. You don't have to have. I mean, we are fortunate. We do. By the way, we do have a telescope in Abu Dhabi that is a 24-inch plane wave that Mike Akey has set up, and we get to use that. But we also have these other scopes, and we can utilize this stuff with these cameras, these sensors. And the optics that we have nowadays just really make it feasible to be able to capture these objects and these deep sky objects with just a backyard telescope. I've heard of people doing these things with 8-inch, even below. I had somebody one time was telling me about at the store at Woodland Hills Cameron Telescope. There, my buddy Daniel was telling me he goes, I can't believe a guy was talking about a supernova with a ETX 90. Like what? And he saw that's the
a small
images.
scope.
Like that is tiny. Like how is that possible? It's like, but you know what, man? With this kind of equipment that is available to us as consumers as well, we don't have to have these gigantic things, and especially the cameras. The cameras have made all the difference in the world for us as far as the quality and the sense of how sensitive they are. That you can get for the money. It's unbelievable what is available to us now that was not available to us 10, 15 years ago, 20 years ago. So it has allowed us, and the fact is we did start with an 8-inch edge. That's what I started with, and I got to tell you, we are 35 miles north of Los Angeles, people. That's where we are located. That's where we are at. Well, I can tell you, you already know, 35 miles north of Los Angeles, we have Bortle 5 skies. I have I mean,
that's on a good night.
That's on a good night, right?
Yeah.
And we got some transparency. I mean, there's times when it's kind of dark out here, but I'm still 35 miles, so but what allows me to do it is the Hyperstar. So I put a Hyperstar on this 14-inch telescope. I'm shooting f1.9.
Yeah.
I mean I shoot 15 to 30 second images. It's like shooting for 5 to 10 minutes on a normal, if I was to put the thing on the back of it, so it's just if it wasn't for the Hyperstar, I wouldn't be able to do this science. I can tell you that right now. It would be very difficult to try to do it, but technology has allowed us to be able to do it and to just do it right here from home.
Yep. And that excites me no end. I mean, that is what turns my crank, and especially the kind of thing that Worldwide Variable Star Hunters is doing with the test data. I love the fact that NEOs are being looked at. It's cool, but it's not my thing. What I care about are these transit curves that are coming out of tests, being able to confirm the these candidates ourselves, that's something I want to get involved in myself. And since I don't have a 24-inch plane wave, I certainly want to look over the shoulder of people who do, and get what observations we can from that. To me, that is the future of amateur astronomy. I get it that taking images is wonderful. The prettier, the better. But that's a frontier that has been conquered. This is new, and this is going to be, in my opinion, the most exciting frontier for amateur astronomy. And so I'm excited about that more than anything else. And so with people like what Econ Greg is doing, and what you guys are doing, and what Mike is doing, Mike Akey is doing, this is like, it's an explosion of people I'm just meeting and seeing. I'm like, wow, hey guys, let me join. I want to be a part of this. So I'm all about it. I think it's great.
It's the guys we have on the team are just exceptional, and yeah, every day is something exciting. I mean, we can't share too much about the test stuff right now, but there are exciting things happening with that, and we're incredible. It's just incredibly part of it. I mean, we have Atlas, gentlemen from Atlas that we're involved with. We have Assassin that we're doing supernova stuff for.
That's right.
It's incredible to be part of these guys. I sit back, I look at guys like Sam, and I'm in awe. I'm like, wow, it's incredible to see these minds in action. I tell Akey all the time, I go, man, I'm just here for the ride, man. Like my son and I, we're so new at this. I don't know, I'm the guy that, hey, you tell me where to point the thing, and I'm going to point the thing, and I'm going to get those images for you.
Yeah.
And then we send it to the people that can really measure the data and do those things. But my expertise is collection, and this kind of started too, because about a year ago, I don't know what happened to me in my life, but I started getting pretty heavily into the history of astronomy. And I was sharing with you the other night, I have a pretty good astronomical library set up here, and I started getting really fascinated with the 16th, 17th century guys, and guys like William Herschel and Caroline and these other people that they were doing so much with so little. And that's what blew me away. It's like these guys were like really giving so much to science, and they just had nothing as far as equipment goes. And the majority of their stuff was pretty spot on, in a lot of ways. And you sit back and go, wow, that really was meaningful. So when my son and I started looking at this, I said, Brendan, we need to do something that kind of contributes. I mean, I love putting the eyepiece on and looking and doing those things, but can we collect data and contribute to humanity and to those things? And that's how it started, was really through those, studying the history of those guys and what they did. And it's just an exciting time, man, to be in astronomy. I got to tell you.
Yeah, well, it's an interesting comparison, because back in the days you're talking about with Herschel et al., these were back in the days of gentlemen naturalists, right? These were like
Absolutely.
Darwin was one. They were already independently wealthy. They could, study science at their leisure, and did so, and they were the primary drivers of our knowledge. The professional astronomer and professional scientist didn't come around until the 20th century. But, so it's an interesting comparison, because now we're kind of back to that, where we may not all be people of leisure, or country gentlemen in the estates who could, had massive wealth. But what we don't have in wealth, we make up for in leveraging our technology to get us to do these things. And so we have that now. And, I don't know. What's humbling to me is that even though I spent my career doing things like, I was a software engineer, my strength is data management and data pipelines and calibration and all of that kind of stuff, just from raw data, and also controlling and programming cameras. I realize now that I've retired from that I can do this as a hobby on my own with equipment that I can just buy. And right. That is astonishing to me. I mean, the Department of Energy had to give a grant and the National Science Foundation to give a grant for this 500 megapixel camera for the Dark Energy Survey. That kind of stuff, while it's important, you need it. You got to be able to see magnitude 22 galaxies with it, things like that on a 4-meter telescope. You can have a 14-inch scope or a 24-inch plane wave or something like that accessible to you, and do very, very similar sky survey work. So it really is a golden age. And it's interesting because it's very similar to, although they had to invent their telescopes. I think Herschel had to invent his telescope that he ended up using. But, we do live in a very similar time. That's an interesting comparison.
Yeah, for sure. And like you said, I mean, the imaging, I get all the time. People are like, "Hey, when are you gonna send some pictures, some pretty images up?" I get that, and I go, "Hey, you know what? I leave that to the guys that are the real experts of that. The Dylan O'Donnells of the world, like that spend the time processing, getting it really right, getting that data right. That is an art form in itself, and I totally admire those guys, and I love looking at those images.
Yep.
It just we just love the science. Where I'm all about, the more raw the better for me. That's what I'm about.
Yeah. And there's a thrill there. I mean, there's an absolute thrill. The first time you take a picture of the Orion Nebula, there's a thrill, but there's nothing like seeing a light curve that you've generated with your stuff of a planet going across the face of a star, or confirming a supernova, or whatever it is. That's more exciting to me.
Yeah, and you're right. I mean, just 2 nights ago we were imaging a couple asteroids, and they were. I'm still testing this 14. This 14, just testing the limits, and we were looking at some that were about almost 18 magnitude, and I was capturing them, and I took measurements, and I submit them, and the next day there they are in the Minor Planet Center as far as the in the as accepted observations.
Yep.
And I got to tell you, man, it's like Christmas when I see that. I go, oh my gosh,
Congratulations!
It's just exciting, and we've had a number of them that we put in there. We got it pretty figured out now, but it's like, wow, we're even going deeper, because we had an 11 before that. I was not able to capture 18 magnitude and 11, but with a 14, it's like it's kind of opened up a whole new realm for us. So
yeah, I'll bet.
It's just exciting stuff. Yeah, man. We just love it so much, man.
Okay, before
can I mention something real quick?
No, we're done with you. Sorry, Sam. Bye.
Oh no.
Yeah, of course, man. Go for it.
I was gonna say, I'm directing this at you, the stream viewers. You guys, don't think I'm talking to you specifically, but I am talking. You specifically are not any different from what I am. I am an amateur. I have not gotten a PhD. I don't have any kind of professional background in this. I'm exactly the same as you are. So if I can do this astronomy stuff, then you can do this astronomy stuff.
That's true.
You have the universe at your fingertips in a way that you have never had it ever before. And there is nothing stopping you right now except for your own inhibition to doing it.
Wow.
Yeah, let me ask you, Sam.
Well said.
Let me ask you, Sam, do you even own a telescope?
No, I don't.
You know what I'm saying? I mean, I brought that up. I bring that up to people all the time. I go, this guy is doing this work. He doesn't even own a telescope, people.
Yeah.
He doesn't know one.
Well, a lot of people don't know that, you can get access to the best data, the best images ever taken Hubble data is free. So is all the stuff that ESA takes, and ESO, all that data, you can just have it. It's yours.
Yep. So is DCAM.
DCAM, that's right. That data is, if it's paid for by the taxpayer, it is available for you to use after an embargo in some cases. But we're talking a year most. But that data is out there. It's free. It's yours. You want a Hubble image? You could say the Hubble is your telescope, because it is. You paid for it, and the data are there for you to take. And what better image to have than something taken by that? So. That's right. All of this is accessible to you. So that's really well said, Sam. What are you studying in college, by the way?
I'm studying music. I'm kidding. I'm studying astrophysics.
Well, a lot of astronomers are musicians.
Yeah,
so that's
true.
okay.
That's not...
that's kind of my main thing. I'm actually, my main job is I'm an audio post-production mixer.
Oh God!
I mix television shows and film trailers and stuff. So, I do a lot of work for a lot of things that you guys are familiar with. I've done stuff for Marvel and Disney, and a lot of the marketing that you've seen on television I've mixed. So I'm actually a musician. So I tell that to people. Go, musicians could be astronomers too. So it wouldn't have been odd, Sam, for you to say that.
Okay. Well, I want to go real quick because I forgot to do this at the top of the Hangout. Can you show us, Mike, the orbit of this thing? I mean, we got the simulation from Sam, but you have another view of this orbit.
I'm going to show you guys this.
Yeah, I forgot to show that.
So if you guys haven't looked, there's this CSS orbit view that our friend there, David Rankin, wrote, and this is on the Catalina Sky Survey's website. This actual
that's a nice site, by the way.
Here. So yeah, it's a great site. But basically, what you do is you just put your object designation in there, and then just hit this Find McGlure button, and it's going to show you where where the orbit of these objects are, and then you can move them forward and back. And you can see this object is obviously right now, it's because it's so close to us, it's cruising along with us. Now Sam kind of showed that simulation of what would probably is going to happen to it, but I love this software because you can just move this thing forward and back, and then it kind of gives you the actual distance from the Earth in AU and distance from the sun as well. And then you can kind of move this thing around. Yes, sir.
But the simulation I had was it going back in time. The thing right now is leaving Earth orbit. What you got right there is what its orbit is now after leaving Earth orbit. So
yeah,
my thing was going backwards. Your thing's going forwards.
Right.
That's a good distinction.
Right.
All right. And
but we use this all the time though, because we'll put in objects because I want to see what, and it'll show all kinds of various orbit tracks of where things are at. It's just a really nice little way to see these things.
Yeah, that's good. I wanted to point out this website because it's a really great place to go to play with some of this stuff and to see for yourselves what these objects are like and whether or not they are, something you need to worry about. Because we get a lot of people were worried about this thing. God, it exploded on the news, didn't it? I mean, people were just like,
"Oh, yeah." Well, look, we get a lot of explosions on the news anytime something comes in close. I've had, Sam knows in the last few months we've had a number of objects that we've just discovered that were like, whoa, that came really close to us, and we didn't see it. When the sun's at its back or something, it's hard for us to see some of these objects, and there's so many of them out there that sometimes we don't see them till they're right on top of us, and we don't know.
Yeah, we can't spot half of everything out there because it's coming at us from the sun and not from the sun. The opposite.
Yeah. So it's like that's why this data, observations are so important. So when something pops up, we can see. But yeah, it definitely exploded. We get, as I said, I get all the time, man. People are going, "Oh my gosh, did you see this? Did you see that?" We also got to put some stuff in perspective, on some of this, because I've had some people be concerned, and look, we're paying attention to these objects right now. There's nothing that's going to hit us and is harmful to us at this moment that we need to be concerned about. I told somebody the other day, I said, look, it's much more relevant that you could get into a car accident driving to your work than get hit by an asteroid today. So please don't lose sleep over these things right now, but yeah, it's like Sam said, it is tricky because some of these come around the back of the sun. We don't see them. And these observations that we take are very important. But yeah, don't believe everything you see in the news headlines, because sometimes they're looking for the glory of the doom and gloom.
I know we were talking about Betelgeuse the other day, a couple weeks ago, and I was showing a Tech Times website article on that about how it was full of contradictions. It was almost like it was written by some bot that just copied and pasted a bunch of phrases and put it in an article that made absolutely no sense. So you definitely want to do some thinking for yourself with this stuff, and that's why websites like this, streams like what Asteroid Hunters is doing and the kind of work that's out there, you guys can become a part of and interact with yourself. So these are all resources that we have now that we didn't have just last year. We didn't even have this stuff, right? So this is all new stuff for everybody. The Worldwide Variable Star Hunters is just getting started, and their work is ramping up. So all of this is at the cusp of some really exciting times.
Yeah, for sure.
Okay, so go ahead and stop sharing your screen, and I'll do a couple. Okay. Let me read a couple of things here from the stream. Oh, I want to ask you about Apophis real quick. So astronomers, professional NEO guys, are really excited about April 2029 because this really large asteroid is going to make a very close flyby with Earth. Are you guys going to be able to do any Are you able to do any observations now of Apophis, or is it out of range of your stuff? And when it is, do you look at it when it is in range?
Where's it? Well, if it is in range, and so what I'll do is I'll generally, for myself, Sam can answer some of this too, but for us here, what we'll do is, we go into the database every day for the Minor Planet Center and basically look up stuff that they classify as what needs orbital, improvement, or they need data on. So depending on where Apophis is at this given time, it may be too dim for us to see. I'm kind of limited to about magnitude 18 on what we are doing, plus obviously position in the sky. is a big factor because we've got a few little mountains around us and kind of the position of where we're at. But yeah, I'll basically go on there and kind of catalog and figure out what does it call for, what is it not, and usually there's a handful of them that they need data on, and so we'll go through that. I'm not exactly sure where Apophis is right now.
I can answer that.
Sam, I was just going to say, Sam could tell you in a second here, So why don't you go ahead?
Where is it right now, Sam?
Where's it at right now?
Right now, Apophis is at right ascension RA 337 and declination 13 degrees north. It actually hasn't been seen in a very long time, from 2015 to about a month ago. But last month, it actually got into a really favorable position to be seen, and right now is actually around magnitude 20 or so. And so people are eating it up because not only is it going to be coming really close to us, but we actually haven't still completely ruled out it may be impacting us in the future. It's really unlikely. I want to be disclaimer, it's very unlikely.
Well, certainly not in 2029, not in 2036, but maybe the 2064 one. Is that right?
Yeah,
the earliest impact chance is 2060. And the total chance of it hitting us anytime in the next 100 years is only 1 in 100,000. So there's a 99,999 in 100,000 chance it won't hit us.
It's not zero, though.
We're doing our best to make it zero.
Exactly. So, and I'm looking right now. There are, I can tell you right now from there are 4,520 observations recorded on it. Sam is right. It was kind of not seen from about 2015. We picked it up. Somebody picked it up in 2019, couple observations on it, but really it's from about January till just a few days ago. What's the date? 27th. The last observation recorded here is on February 22nd at 19 magnitude from observatory code 511. And position in the sky where it's at right now. If you were to say, hey, can you look at it? It's plus 12 is the deck, which is good for me, but it's at an RA of 0.3, which would put it pretty far in the west. When the sun goes down, I probably wouldn't. And at 20 magnitude, I wouldn't be able to capture it. But there are definitely some observations that are happening right now on it from the minor planets.
Well, I just wanted to add that the reason it's so exciting, especially the 2029 flyby, is that this will be the closest something this large has gotten this close in, I think, close to 1,000 years. And so astronomers want to use that flyby opportunity. I just made a video on this. This is why I know so much about it. They want to use this opportunity to study what these objects are like. It's going to get underneath the orbit of geosynchronous satellites, so it's going to get really close. 1 billion people will be able to see this thing with their naked eye as it flies by. So this will be a big deal. And I just wanted to mention it because 2029 is a long way away, but it's still part of what you're doing, and it's interesting to a lot of us. Who used to be concerned about it, but not so much anymore.
Well, if it gets close enough and bright enough, we will absolutely be looking at it. There's no question. So.
And I just wanted to point out that Econ Greg says on the chat here that he can get down with his RASA to about 19 or 20, magnitude 19 to 20.
The challenge and Greg's right, but the challenge is that we're shooting 15-second exposures because we're going after rocks that are flying around. So
that's right. What is your longest exposure that you can generally take?
For me, I can, I'm guiding. I can take a 3 or 4 minute exposure. So we definitely can get down into that realm. But when you're starting to look at these things that are flying around, you have to shoot short exposures. So you're only limited to that, and you can't take super long exposures. You get trailing and those kind of things in the images, and then it becomes a problem because you can't measure them correctly. So he is right. You absolutely with us we could get 20 magnitude with our 14 if I'm doing some deep sky observations. Hence the reason why you can get we capture supernovas. Somebody said, how do you do with a backyard piece of equipment? Well, that's how we do it, is because yes, we take long exposures. You can get down in the magnitude for sure. But with these objects, they're moving around. So I can't sit on that for 5 minutes,
But you're also shooting at like f2, right?
I'm shooting at f2.
Yeah.
But generally, my observations, my exposures range from 15 to 30 seconds. That's it. When I start getting more than that, and I start stacking those images to see, I cannot get the measurements correct the residuals are not good, and they don't become good recorded images for observation for orbit at all. So
Okay.
And that's the reason, like the Catalina Sky Survey that they're shooting. When they do follow up, they're shooting about F2 with theirs. They can get about 20 mag2 with their 1 meter, but they're shooting F2 as well. But they can get about 19 and a half, 20 mag2 with theirs shooting 30 seconds. So
Right.
but that's generally the exposure time that we're working with is those times.
Okay. Well, we're running out of time, so I just want to let people know how they can find you, Mike and Sam, so that they can join your community. When are you streaming tonight?
What is tonight? Thursday? It's possible. I'm not sure yet. Possible. I got some other stuff going on work wise. I might have to deal with, but
no,
if not,
you got to. No, you
I
can't.
will. I know. I can't deal with work, right? If I don't stream tonight, we will definitely stream beginning next week.
Okay.
We got some stuff happening this weekend, but
yeah.
But yeah, we are on Twitch, Asteroid_Hunters.
Yep.
Maybe if A-Key's listening, we can drop the we'll put the link there in the description below.
I think I also have it in the description of this hangout as well. And definitely check out Econ Greg on Twitch, as well as does A-Key? He doesn't stream as much as you do. Is that right?
He doesn't stream, but the planeway was down for a few weeks with some equipment repair stuff.
Okay.
So, but we're back up online with that, and he's going to be on more. So the other thing we'd love for you guys to do is I want to send you a link to our Discord, you guys, because we there's a lot, we're building that community there, but we actually have an asteroid science tab that Sam leads, and he leads discussions in there. And if you guys want to pick Sam's brain, because he's so knowledgeable on these things,
Definitely.
we'll put a link in there for the Discord, and you guys can talk in there and pick his brain about these things. And we have all kinds of other channels in there to look at, but we're really trying to build that community out so people can ask questions and be part of this.
Yeah, it's fun. I check it out a lot, so it's definitely I'm there as well. And so yeah, good advice. All right, well, thank you very much. So Mike Forsland, he's the runner of the organizer, the operator of Asteroid Hunters, a stream. You also have a YouTube channel of the same name. Asteroid.
I do have a YouTube channel, and we're we do some reviews for telescopes.net up there. I have been throwing some of my live streams up there lately. We kind of have a mix mash of equipment, and then also just the live stream stuff. So I like the one you and I did the other night.
That's right.
I put up there on YouTube so people could see what's going on. So, but yeah.
So
we have both. I'm working on both platforms. I haven't. Am I partial? I don't know. I'm like you. I know you're on both platforms now too, Tony. We're trying to figure that out.
Well, I'm bigger on YouTube than Twitch. My Twitch profile is real small, but I will plug myself. On Tuesdays, there's T Cubed, which is Tony's Twitch Tuesday, 3:00 Eastern on Tuesdays. We just chat. We just mumble at each other. I get my community and we love getting together. I like my guys, Galaxia and Peter Q and the Larry Keese and all those guys show up, and we just talk about whatever interests us. So you're welcome to join us on Tuesdays. I'm also going to be live streaming on Twitch as I get more of the equipment issues worked out, but I'm interested in also promoting a lot of what Mike Akey is doing as well. So I might try and do some more Twitch stuff with him on that if possible. And I don't know. So keep your eyes open for all this stuff. I'm going to have to cut it here because we're out of time. But next week we will be back with the EV scope. So if you want to learn more about that with Unistellar, please join me then. Also, I need to just also plug real quick. I've got a new podcast. I'm already doing Space Junk Podcast with OPT, but I just started this. My wife wrote it. It's a podcast for young kids called Space Cadet Podcast. It's going live today and tomorrow. The first 10 episodes have been recorded and produced. I'm uploading them now. Space Cadet Podcast. If you've got a young child, or even if you just want to listen yourselves, each episode's only about 5 to 7 minutes long, and I've got episodes on how do we know there's aliens out there? How many planets like Earth are there? How to become an astronaut? So please check out that podcast wherever you listen for podcasts. So that is live today, and I'm still uploading the rest of the episodes. The first 4 are up. I'm getting the other 6 up in the next couple hours. Okay.
I just dropped the Discord link in the chat for you guys, and then we'll make sure Tony has that as well.
All right, thank you. Yeah, I appreciate it, and I'll put it in the description of this video. Okay.
Thank you, Tony.
You're
What an
welcome.
honor.
Thank you, Mike. Thank
Appreciate
you, Sam.
it, man.
Best of luck
Thanks
with
so
what
much
you're
for
doing.
having me.
Yeah, you're very
Yeah.
welcome. Thanks for joining on such short notice. Okay, I want to
Our
thank you
pleasure.
all so much for watching. I had a video capture card die on me, which is why I am now looking at my webcam instead of my other camera. So anyway, it died during the stream. Anyway, thank you all so much for watching, and as always, keep looking up.